We would like to calculate relative cluster distances. For example, we have the Virgo cluster on the left and the Fornax cluster on the right. We would like to know the relative distances between the two, or if we know the distance to 1, we would like to know the distance to 2, knowing the distance to 1. The things that we need to know are their apparent magnitudes of the two different clusters to find the distances or the relative distances between the clusters. These images were taken by telescopes owned by ESA and NASA. Let's say we're given a Virgo cluster distance of 54 million light years and a Fornax cluster distance of 60 million light years. We want to find the difference in apparent magnitude. So in this particular case, we're given the distances and we want to find the relative difference in apparent magnitude. So here's the equation that we're going to use. Apparent magnitude of cluster 1 minus the apparent magnitude of cluster 2 is equal to 5 times the log of distance 1 divided by distance 2. On the left, we just have a general diagram here. It's a sketch. We have apparent magnitude on the left and radial velocity on the horizontal. We have two different clusters. They're shown by the dots. One set's in blue and the other set's in black, and we drew average lines between them. So you can see we have pretty linear relationships. If the two clusters of galaxies were at the same distance, their dots would fall on top of each other and their average lines would fall on top of each other. If they're at different distances, they will have two different sets of apparent magnitudes, and one will be shifted more to the right than the other one based on their galactic redshifts or their radial velocities. So this is the case that we have. We're looking at two different clusters of galaxies. They're located at two different distances. They're not at the same distance. Therefore, they're going to have two different apparent magnitudes in the sky. We want to find the difference in their apparent magnitudes. So let's go ahead and solve this equation. We want to solve for m1 minus m2. So this is going to be the apparent magnitude of the Virgo cluster minus the apparent magnitude of the Fornax cluster. And that's going to equal 5 log, and I need two distances. The distance to the Virgo cluster is 54 million light years, and the distance to the Fornax cluster is 60 million light years. Because they're both in the same sets of units, I'm not going to put the units down because the units cancel, and I'm just going to put the numbers down. So we need to find the log of 54 divided by 60. So let's go to our calculator. Just type calculator into any search engine and you'll get a calculator, usually. I look in Google and I get this calculator. I type in 54 divided by 60 and I get 0.9. So now I want to take the log of 0.9. Oh, that didn't work. 0.9, close parentheses, enter. So now I have my value for my log, and I have to multiply it by 5. So then I multiply by 5. And I have a value of minus 0.228. So since the 8 is higher than 5, we're going to round this 2 up to 3 to get minus 0.23. So our value is minus 0.23. And then we have our difference on the left, m1 minus m2. So let's take a look at this here. m1 is at a lower number than m2 in order to get a negative value. Since m1 is at a lower number, it is brighter than the one at m2. So Virgo cluster is brighter than the Fornax cluster. So that's one example of how you can use two different cluster values to find a relative difference. In this case, we found the relative apparent magnitude.